Today I'll be solving some challenging IGCSE math questions. So if you want, you can bring a pen and paper and try to solve them yourself. So first I'll start with some questions about the previous topic, which was the graphs in practical situations, and then I'll start with the challenging questions. So let's start with this. Below is the distance time graph describing a 1500 meter race run by Chris. Work out the maximum speed he reached during this run to 3 significant figures. So as you can see here, this is a distance time graph. So in the distance time graph, the gradient represents the speed. So of course, the higher the gradient, the higher the speed. They want the maximum speed, so the gradient must be highest. So here, if you see this part has the highest gradient, and so this should have the highest speed. So here, if we draw a line like that, that's 600 and that's 72, and we can calculate the speed as 600 over 72, which is equal to 8.33 meters per second. And if you're not sure, you can find the speed here as well, and it will also show that this is the maximum speed. Okay, so this is the next question. The diagram shows the speed time graph for part of a car journey. The speed of the car is shown in kilometers per hour. Calculate the distance traveled by the car during the 3.5 minutes shown in the diagram. Give your answers in kilometers. So here, as you can see, they made the words bold, so that's hours and minutes. In the x-axis, it's in minutes, and the y-axis is in kilometers per hour, so you have to take care of this. Okay, so as you know, to find the distance, we have to find the area under the graphs. Okay, so I drew the lines so that I can make the shape, find the area of the each individual shape. So here we have a trapezium, a rectangle, and a trapezium. What you can do also is you can find the area of the whole rectangle, this rectangle, and then subtract the area of this trapezium, and I'll do just that. Okay, so I'll find the area of the whole rectangle first. So 120 multiplied by 3.5 divided by 60 so that we can convert it to hours, and that would give us 7. This is the area of the whole rectangle, and then we find the area of this trapezium, which is half into the sum of the bases, that's 2.5 divided by 60 plus 3.5 divided by 60 multiplied by the height. The height here is 20, as you can see here, multiplied by 20, and the answer here is 1. So if we want to find the distance traveled, we can just subtract 1 from 7. That would give us 6 kilometers, and that's the distance traveled throughout the whole 3.5 minutes. Okay, so this is one of the harder questions. It's in the hexagon ABCDEF. AB is parallel to ED, and AF is parallel to CD. Angle ABC is 90, and angle CDE is 140, and angle DEF is 120. So try to solve it yourself and watch to see the answer. Okay, they want the angle EFA, which is this angle right here. So of course this is a hexagon, it has 6 sides, 1 2 3 4 5 6. So a hexagon would have the angles would add up to 720. How to know that? You can use the formula 180 multiplied by the number of the sides, which is 6, minus 2, and that would give us 720. Okay, so the angles, all the angles should add up to give 720, and that's how I'm going to be solving it. So first we have this line right here. I will extend it a little bit, and we have this line. Okay, so you have this line which is parallel to this, and this line is parallel to this. So as you can see here, this and this are parallel, and there's a transversal here. So 140, this angle and this angle are supplementary. So they add up to give 180, and so 140 plus this angle, I'll call it x, is equal to 180, and x is 40. So we know this angle as 40 degrees. We know this angle is 90, and we can find this angle. So 180 minus 40 plus 90 would give us this angle. I'll call it C. Okay, and that would give us 50. So C is equal to 50. Now if this angle is 50, of course we can find this angle, since this is a straight line, so they add up to 180. 180 minus 50 is equal to 130 degrees. So this other angle is 130. We found another angle in the hexagon, and of course here we can find this angle too, since this line and this line are parallel. So this angle and this angle are supplementary, so they also add up to 180, and so we can say this angle is 140. These angles are equal. Now we have all of the angles in the hexagon except for one angle, and so of course we can just subtract the angles from 720, and that would give us the angle we need, EFA. 720 minus 120 and EFA would be equal to 100 degrees. Okay, and that's this question. That's the answer of this question. Okay, so we have this question. This figure has rotational symmetry of order 3. How many lines of symmetry does this figure have? So if we try to add some lines here, something like this maybe. Of course you can see this is not symmetrical, and it doesn't have any lines of symmetry, and so the answer here is of course 0. Find x. So now this is a good question. So x is right here, and they told us that the figure has a rotational symmetry of order 3. So if we rotate it, x would land at 40. So let's say we rotated it, so it will look something like this. Of course it has an rotational symmetry of order 3, so it'll still look like that. And now this would be 40 when you rotate it, and this would be x, and this would be y, and this would be 53. So So as you can see here, when we rotate it, x lands on the 40 angle, so x would be equal to 40 degrees. So now to find y, y is right here. When we rotate it, it will land here and it will land. Okay, so now we know that x is equal to 40 and x is right, x is equal to 40, and the 53, when we rotate this shape, 53 would land right, would be right here. This would be equal to 53, and this would be y. And here we can this is of course 360 degrees. We have three angles, so we divide by 3. Since it has a rotational symmetry of order 3, it is symmetrical, and so if we so these angles should be equal. So this angle is equal to 360 divided by 3, which is equal to 120 degrees. So we have this angle as 120, we have this angle as 40, and this angle as 53. So we can find y. Y is equal to 360 minus 40 plus 120 plus 53. Since it is a quadrilateral, and in quadrilaterals angles add up to 360, so this would give us 147 degrees as the answer. Okay, so this is the last question. So here in the diagram, the circles have center O. AB is a chord of the larger circle and also tangent to the smaller circle. AB is equal to 14 centimeters and the radius of the larger circle is 10 centimeters. Find the radius of the smaller circle. So of course, if this is a tangent, if we draw a line from the point of tangency to the if we draw a line from the point of tangency to the center of the circle, this would be 90 degrees. And if this is of course 10 centimeters, so we can also draw it here since it is a radius. So this is 10 and this is 10, and now we created a triangle. This is 10 and this angle is 90 degrees. We need this radius of the smaller circle, so we need this line right here. We need this line right here. So if a line from the center of the circle intersects with a chord and it was perpendicular, so this angle was 90, it has to cut through the midpoint, so these are equal. And here we can say that this is 7 centimeters and this is 7 centimeters, and we have this as 7, this is 10. We can find this using the Pythagoras theorem. So 10 squared is equal to 7 squared plus the radius squared, and r is equal to root 51. Thanks for watching today's video and see you next time.